pertaining to clasps are clear. Now we can go to the next step. How did we evolve to more complex dentures and how we got to overdentures? Of course, we speak about history here, obviously, but you know, a good friend of mine in Switzerland says fashion is just a matter of patience. You never know when we discover materials that allow us to come back to simpler methods. You see, we went from simple to complicated systems, yeah, attachments between 1930 and 1960, yeah, after Steiger especially. From simple to complex devices, you know, more interesting or even crazy designs. Since 2000, we started to do overdentures more and more. That was something known a long time ago, but the overdenture was applied widely after 2000. Yes, so that's true, it's history. But let's see how we did it. You see, the logic, why it came. See, the simple acrylic was inesthetic because of the labial part of the clasps. Secondly, if those clasps were fractured, they had to be replaced. The remaining teeth were there as they were, but it's okay, isn't it? Well, no, because sometimes patients want the teeth changed. They want the remaining teeth to look better. So if we do that, if we try to make remaining teeth looking better, then we move to what is called combined denture. We'll see what it is. Well, anyhow, so first thing was, why don't place the clasps on the oral side of the teeth? That was Steiger's idea. Second thing, why don't we create a preparation on the pillars on the abutment teeth to create space for more massive attachments? And then why don't we cover, that was the third idea, to cover the remaining teeth with crowns and to place some attachments inside of those crowns or outside of those crowns. So we had the combined denture, fixed and mobile, that's combined, and attachments that allowed to fix the fixed part and the mobile part together. Okay, we won't discuss all of them, but we will exemplify the most frequently used. First, there were systems, resilient systems, pin and spring, the hinge or the coulisse. The hinge is still used up to this day. It was the best of those types of systems. The second variant was half-rigid systems or attachments. That means inside of this system, be it bars, spheres, coulisse, they had something plastic inside, right? Some resilient material inside. The bars, again, the vertical solutions as they are called, or the coulisse, or the spheres, dental spheres. Then we did rigid systems. That's a vertical system with associated milling, and it was rigid because the other systems were allowed too much mobility. And then there are telescopic systems, direct or indirect, having some gold galvanoformed intercoping. But then if you use all this, you need more space. You need to prepare the teeth more. Now, something has to be clarified, that those systems are either force breakers, like, so the force is taken also by the mucosa, because the attachment allows or has has a spring there that allows to break the force. It's a spring that breaks the force. Then we have equatorial systems, spheres or bars. What does that mean? That means they do click. Okay, they do the sound of click. The retention system passes over an equator of the attachment, and that goes under the attachment, and then it does click. Yeah, it's quite similar to cast clasps that were going under the equator, but of course this is the equator of the system, not of the tooth, right? We'll see it in detail. And there are other type of special attachments. They're called frictional. Yeah, coulisses or vertical systems and telescopes. Let's take them one by one. You see, this is the coulisse, the vertical system. The red part is the part that will be fixed to the pattern, the wax pattern that will go on the abutment teeth. Of course, after the casting, that red part, plastic red part, will become metal, and the other part will slide along this extracoronary vertical system or coulisse. See, this metal part holds the pin and the spring together to press against this coulisse, this vertical solution. Matrix and patrix, that's how they work. Right? You see the pin, that round thing inside, and this pin is pressed on by a spring that is inside of the mobile part. So of course this allows a little bit of movement. The pin actually moves a little bit as the spring allows, and allows quite a bit of a mobility of this type of attachment. In the same time, it keeps the denture in the mouth, but allows it to sink into the gum. Those systems, those attachments, nevertheless had too much mobility and created problems. Too much mobility is not good. Okay, now the second type, the hinge. Well, this is way more evolved. It only allows the distal sinking of the saddle, and that's what has been conceived for, uniterminal solutions. So you see, this is the spring. You can activate. You see, it has a screw behind, and you can activate it or deactivate it. Decide how much force the patient will feel when inserting or disinserting this unilateral saddle. That's for unilateral saddles. But this is difficult. You see, this red thing is very difficult to cast, because you have to have a perfect match in between the two parts, the fixed and the mobile. If you do it in gold, well, you can do it, but is gold strong enough? That's another discussion. For this one, together with noble metal, I've devised a system with a notch there. This was made by the company in metal, and it was an overcasting of this metal part with the wax pattern that would be the covering of the remaining teeth. We will see it clearly in detail how we were doing it. So this is the patrix. It can be solderable, it can be overcastable, or it can be in plastic, castable as such as this one. And the mobile part is the white one in our picture now, and that will be included in the saddle. So again, you see, the Italians, because this is Italian conceived and made, you see, the Italians always model the teeth to the final shape, and then they will trim out as much as they need for the part that will receive the ceramic. So they remove like 1 millimeter from there, then they know exactly, okay, at the end, after I place 1 millimeter of ceramic, I will have this labial side as I modeled it initially, right? They see better if they do the full anatomic modeling. So you see, this is glued there, I mean fixed in wax. Yeah, this is very complicated, but you see, this is metal one. Yeah, of the hinge. It's a technology without duplication. That's very interesting. So once those are cast, this is the golden variant. You see, this can be fixed there. You can use a parallelometer, but it's not important because it's unilateral. So this position is blocked into position with investment material, and then you see this is where you put it in the furnace, just placing a little pellet of gold that will at the high temperature will simply fill the gaps and solder the two parts. That's amazing how they do it, but this is only able to be done in gold, right? Stainless steel, no way. Anyhow, so I have the metal components, 2 crowns. They will receive the ceramic, and on the distal of those two, on the distal crown actually, here I have my patrix of my hinge, and then the matrix that has also glued on another part that now is in resin, as you see it, red, pattern resin, whatever, under wax, picoplast from bread and whatever, special composite that is castable. And see, after we do that, continuing the mobile part, it will be glued, adhesively glued, yeah, resin cement glued to the mobile part of the denture. So now you see it clearly here. It has been painted with pink. When we place the teeth from the distal part of the last tooth to the center of the piriform tuberculum, we only place into occlusion half of this space, but the saddle extends as much back because we want to have a big rest, yeah, on the bone and to reduce the sinking. It can be very interesting and new. It's not true. We have been starting using it in Romania since 2003 after a long break, because I had the privilege to speak about that with the father of the removable denture in Romania, Professor Andrei Ionescu, and he told me that in 82, 83 he did the first system like that in Romania. So it's not something that new. Since 1980, what is still available to this day? I wouldn't do that again, this type. You see, we have implants now. But anyhow, now we talk about attachments, right? So once you have modeled over this whole device, after you model the acrylic teeth or composite, or pink wax, whatever, then, as you see, we make an index of it, silicone index. The teeth stay there, the wax is washed away. This is what remains free. This is something white, like a covering that is applied, that is white painted, and that prevents the acrylic resin that we will place there to get into the mechanism. And then you place everything into position, and all this is going to be filled with acrylic resin. Yeah, you don't have to invest it, you don't have to duplicate it. It's quite simple to use. It seems simple, looks simple. Well, it's not that easy, but anyhow, it's way easier than classical dentures that need duplication. So our patient has a solution for a uni-terminal addentation, class 2 Kennedy. There are other companies that have imagined attachments for such cases. This is not the only solution for uni-terminal cases, right? So now we spoke about resilient systems. Now let's talk about half-rigid or semi-rigid. I have a special respect for bars. Bars with riders, it's what it's called. I think this is the best ever made. Yeah, I think this attachment is the best. But here, in this case, we would have better placed implants. Now, when I'm talking to you, the patient already has implants now, but long time ago, that was like 12 years ago, she believed that she was sick with a sickness, with an illness that prevents her from receiving implants. So she said, okay, let's try to do a removable denture. So the solution, just imagine, I won't let those teeth look like that, right? You guess that here it's just a temporary crown, yeah? And I painted it a little bit to, to trick the eye, but that was a metal ceramic done by somebody, but it was looking like, it was not from that mouth. So the patient wanted better aesthetics of the whole maxillary, not to speak about the inclination, yeah, the malposition of those teeth in the frontal zone. And so we needed a combined denture, right, to cover those teeth somehow, and then implants, or the other way, to modify, to cover this teeth and then to do a denture. Okay, so let's do a combined denture. That's what it is. So you see 3 elements and a bar with a rider distally. This is not orthodox. This is the bar normally is placed like that, interdental, right? Like here, like in the image. Of course, here I draw the metal framework, the limits of what will be the metal framework. This is the master model. And here I prepare all the structure for duplication. I don't want to get into details how this is done. Those are the metal ceramic crowns, almost ready. And this is some accessories for duplication. It's a little bit complicated. I don't want to get into details. It's just to imagine at the end, when I cast the metal part, this shape will remain inside of the metal, right? And in that, I will place the rider that will do the click, okay? Now, you see the metal framework already cast. It is at a distance, obviously. Here is the bar inside this tooth. You don't see it because it's inside of this first removable tooth, okay? It's plated with composite resin. Again, the metal framework is at a distance from the crest because, of course, we duplicated the model. We placed foils on the master model, duplicated, and we already knew, studied about that before. And a happy patient, yeah, happy patient. Well, yeah, aesthetically it's okay, but the main problem is that it's a removable. After 10 years, the patient said, okay, my diagnosis was wrong, so please, I want implants now. When you place implants, is like close air support, right? Like the fighter jets come into the battle. Okay, now another system, equatorial system. You see, the bar also is equatorial, right? The bar is like a drop shaped. And the rider does a click when sits on the bar, right? So it's an equatorial system, click type system. So I combined something. This is, again, unorthodox combination. A bar in between the teeth, a mesial bar on a tooth here, distally positioned, and here I had a sphere system, yeah. And what you see here is the model on the duplicate, is the pattern on the duplicate model. There is an asymmetry here, yes, it's true, but it would have been too much. I could have, extended, but I considered it was not necessary. This is the finalized denture, and we understand that in that molar, we have the rider that sits on the mesial, on the bar that is placed on the mesial of the molar. And here we have the second premolar that hides the rider that goes, again, on another bar that goes interdental. And inside of this one, lateral incisor, we have another click type retentive system for a ball attachment, or a sphere as it's called, ball attachment. So you see sphere and bar. Those are the riders. Those are the riders. I could have placed them on the whole length, but I didn't want that because the force would have been too big. So I preferred to cut them to reduce the retention. So 1, 2 riders, and this is the retainer for the ball attachment. Rain 83 is the company because it has been invented in 1983. So you see this is the root there, the remaining root up there, the sphere-like on the attachment, the ball attachment over the lateral incisor. And you see here the mesial bar. This is a special bar that goes down to the gum. But you see this cylinder allows the equatorial rider to do a click movement and to retain the denture in place. And you see the denture in place now. And now we discuss rigid systems. That's 2B, as we may say. Those are vertical systems or coulisses. The way of working of those is way simpler. You see a matrix, and an intermediate resilient element, the blue one. Now, you understand that both the matrix and the port matrix, so to say, they are castable plastic, and they will be cast together with the respective component. The matrix with the teeth, the metal that will sit on the teeth. The other will be with the denture, and the intermediate element will be placed afterwards in order to ensure the friction. Now, there are situations in which they only sell this matrix and the intermediate matrix, the matrix itself, while the port matrix, I mean the outer structure that holds the frictional element in place, will be created by the technician, but those are details. So those are frictional devices, okay? It's not an equator, it's not a click, it's a frictional system. They are semi-rigid. What do I mean by semi-rigid? See, this is what I'm talking about. This has been changed after 17 years. So it lasted for 17 years. You see the front canine to canine. Another colleague said, no, these teeth have to be extracted. Okay, 17 years, and now we extract them. 17 years later. That's crazy. So you see this first tooth hides the coulisse, or the vertical solution. This is how it looks when you look from the gingival aspect. The frictional system is red here. It's different. It differs from the color differs how much retention you need. Blue, red, whatever. So this tooth includes actually the matrix, or the port matrix, where you place the retentive, actually the very retentive matrix. Now, what's the idea? The idea is that as this matrix being a little bit elastic, this frictional system, it allows a little bit of movement, That's the idea. And when the patient is chewing, there's a distal movement of the saddle, a little bit of it. But the force is broken somewhat by this intermediate component. Of course, on the maxillary, we can do it easier. That's why this denture lasted so long, because it was in the maxillary. And you see, the palate holds it in place, doesn't allow it. You see, it's a massive connector, doesn't allow it to sink too much. because the palate is a biostatic zone, right? Now you see it again, intraoral aspect, labial, and in the mirror you see how it looks from inside the mouth. This is 7 years later, yeah, when we had to place some more resin on the removable denture, because the gum retracted, the bone retracted a little bit. Well, there's another system, again, that's C, semi-rigid, the third variant, C. It's proximal spheres. I don't use them anymore, and I'll tell you why. The pictures are extremely old. That's 2003. It was my first Sony digital camera. It was as big as a classical photo camera. Yeah, it's enlarged. The picture is enlarged so that we can see better. Anyhow, so we have two metal ceramic crowns, united crowns, and on the distal is not a coulisse but is a sphere, a ball attachment, and the retentive element is a device that goes click on that sphere, right? While the two are connected, there's also an arm. Professor Andrei Ionescu allowed me to use this term, shoulder. He was very happy to use this arm and shoulder. Actually, as a friend sets his arm on the shoulder of his friend, right? You see, the palatal part is the fixed part is a shoulder, and from the denture comes an arm, and it's quite intuitive. The arm sits on the shoulder, right, as two friends would go. Now you see the couple system. You see this plastic device. It somehow goes over the equator. Yeah, well, that was a solution at that time. It was very popular because it was quite easy to do technically, but personally I was not very happy with it. So I conceived different systems. Otherwise, this metal is quite hidden inside the mouth. So yeah, well, those are pictures from 2003. You can understand that. But the final aspect is, well, not the best, but yeah, it's better than a clasp, right? And here is a telescope. The telescope, because we had a molar remaining there that was covered with a primary coping. We'll discuss about that. And that's the secondary coping. It was not to be frictional there. It was not meant to be frictional, but just to allow the rest. Now the problem was that we had the rest on one side and we didn't have it on the other side. We did have it on the left, we didn't have it on the right, and the imbalance of it made it to need to be removed after 8 years, if I remember well, because this dentin was destroyed of those teeth on the right, because there was too much strain on them by the movements of the denture. This is how we do it in the lab. This is what I've translated in 2005, I remember well, from Rain Company. That was translated from Italian. They asked me to help with the translation. At that time, this is the milling that was done on the oral side of the tooth. So this is the system, the sphere, and over the sphere we place the retentive element, plastic retentive element, and then this is the foil, wax foil placed over the master model. And now we can duplicate it. You see the next image, the duplication of the model. You can look at those explanations. You find them in English on Rain 83 website. So this is the duplicate model, yeah, investment material obviously, and then you create the metal component that will, like so, will have the arm and the place in which the plastic element will be introduced to go click on the ball attachment. Yeah, that's how it is. how it looks from the lingual side. You see now the retentive element, plastic retentive element, is introduced in the proper place, that is hidden in the first tooth of the denture. You see now this is covered with acrylic resin, and that's the fixed component, that's the mobile component, and combined denture. Combined means fixed and removable. Yeah. Equatorial retention on the sphere. And here is another solution. We can place this sphere on the lateral of a bar, but why would you do that? Well, that's another discussion. I would use a normal bar, but maybe the sphere being a little bit smaller. Anyhow, in lack of space, you could think about such a solution. I don't like it anyhow, but this is a possibility. Yeah. So they were quite widely used at that time, 2006, 7, 2008, 2010, and then, well, people moved to implants after all, right? But those spheres or ball attachments still used to this day. They are slowly removed by other systems, locators, magnets. Yeah, locators seem to be a little bit better. Well, anyhow, but those spheres are mostly used now as occlusal systems, right? Or attachments, not on the proximal, but as we have seen before, after cutting the root, they sit on top of the remaining root, right? But that's over denture. Now the third type is the rigid attachments or systems. Rigid, not because they are different, they're still vertical systems, coulisses, the same ones, but they have a milling associated to them. I've been doing that, maybe more than 100 of this. I gave this up because it was too rigid. And it was very good if you were having distal teeth to sit on, but otherwise the patient had to come for rebasing on a regular basis, and the patient wouldn't do that, and because the distal saddles started to sink in the gum, and then they would create tensions on the remaining teeth, and we couldn't use the elastic effect of the matrix, because I had those millings that was creating everything, all the system to be rigid, real rigid. You see how the arm was getting perfectly into the neighboring tooth, yeah, the fixed tooth. Yeah, you see that this first tooth of the denture has a ceramic covering, is very aesthetic, and it hides the attachment, and then it has a distal part where the pin, yeah, it's called the conjunctor, where we would adhesively cementing the main connector. Yeah, this is gone. This is history. It's absolutely history. So just to have an idea, how we were doing it, the final modeling of the tooth. This is just a demonstration. I did a course then in 2006 just to demonstrate how it is done. This is the castable Patrix, which is attached to the wax. Now we remove the pattern, the wax pattern, and we check exactly on parallelometer where we will be able to do the milling, to know exactly that we don't touch the abutment, or that we leave too thin layers of our metal coping. And then we start milling. See, the wax is a special wax. You see, those are the interlocks, as they are called. It's details that I don't want to get into them. But it was a very complicated milling. You see, that's mesial and distal interlocks, 0 degrees, wall, shoulder, double shoulder, upper and lower shoulder. Yeah, and that's the coulisse, the vertical solution. This tooth, of course, would have to be more, refinished to create space for the ceramic, but the ceramic had to be at a distance from the mobile element, so we needed to do another small wall against which the ceramic would stop, Yeah, right. So that's how we were doing it. It's incredible complication at that time, but that's how we were doing. That's why we're working 2005, 6, 7, 2010. And just there, you see in the middle, we would be able to place the ceramic after we cast this this system. So after casting the fixed part, our crown, it's a shoulder preparation, as you can see on the tooth. And now you see the white retainer. It was a special retainer just for positioning. The port matrix, which is here castable. And now how do you fix this one to the main connector? Well, we were designing, we were creating the arm, the removable arm in resin, yeah, castable resin, which is blue here, you can see it, that would 10% was 10% copying all the details of the milling, right? 0 degrees. That was very, very difficult to make, but it could have been done. I mean, we did it many times. I think the first course was in Bucharest, the second one was in Iași. Very interesting. You see how detailed this can copy all the milling, this castable material. And once we united this with the port matrix, we remove the working matrix, and then we would cast it separately. You see, this is the sprue, the part where the sprue came in. We will adapt it immediately, and here inside of this we have this coulisse hidden, the space for it, and here we'll place ceramic over the two to get maximum aesthetics. This is the conjunctor that I was speaking about, and this is the matrix of the conjunctor that would be connected, glued to the wax pattern of the denture. This is history, so please remember, this is just an information about what we were doing a long time ago. Now, to adapt the removable to what will become the fixed part, we were doing it with diamond paste, and there was an instrument that would hit 60,000 times per minute, and slowly, in and out, we would introduce the two parts. This is the paste. That was, again, back in 2006. That's the parallelometer. And we apply this paste, diamond paste, on the milled surfaces. Yeah, it doesn't have to be much. I don't need to have too much of it, but it has to be there in order to be able to slowly, diamond against metal, be able to trim one part to the other part. Now I introduced the retentive element, plastic retentive element. This white one was just for purpose of working in the lab. Otherwise we had red or blue according to the amount of retentive force that we wanted to get. And now I tried to put it in. It goes quite well, not perfectly. You see, that's till where it goes, and then slowly you put it in, you put it out. Yeah. Go in, press on the tooth, press on the other side, go out, go in, go out. And that's how we were creating the perfect fit in between the two. This is probably the most precise dental work that we did in the lab. It required the maximum of precision. And then, yes, slowly we would trim the margin of our removable part, make them sit and fit together. So this is how we refinish the whole structure. And yes, the adaptation was really amazing. Huh? And of course, that part we would remove it completely. It was, and here you see the conjunctor, the Patrick's of the conjunctor. You see all the components here again. That's what you were getting in the end. That's the tooth that was containing the attachment, the resilient element, the arm that would sit on the shoulder, the interlock there, same on the other half arch. It's a principle that if you do frictional system on one side, you have to do frictional on the other side as well. You can't go equatorial and frictional together. You go either equatorial or frictional. So you have to choose. You can't use both. If you started with one, you do the same in all places where you want to have retention. So those teeth, they would fit perfectly with the crowns on the remaining teeth, right? And in order to make it absolutely passive, we use that diamond paste. And then we would cement these parts into the conjunctors in order to create everything as one single unit. Yeah, but this is after we place ceramic on the first tooth. This is the image. That's how they fit. It's fitting well. It's fitting well. It's not that easy to get this, especially if it is cobalt chromium. Yeah, with gold it would have been way easier. It was way easier. This is the master model. Yeah, we come back on the master model and we will glue the two components to the main connector. Yeah. And now the fourth type are, as we said, telescopes. And I will show you direct friction telescopes, and I'll explain a little bit what is those that have mediated friction. Yeah. So this is the denture, as you can see it. What's the big idea? It's very simple. It's like a bridge with saddles like a denture. It's a denture bridge or a bridge denture. This can be a bridge. You imagine that, right? What is there? Well, there is a saddle, because I want to be able to remove everything in order to allow the patient to clean. But it's a denture at the end. The denture that instead of being a bridge, that instead of being cemented on the teeth, will be placed on the remaining teeth. Those are the remaining teeth. I was not able to do very nice pictures at that time. The saliva shouldn't be there, sorry for it. Those are teeth prepared for impression, retraction, quadrant. This is the primary copings, yeah, the primary crowns. There are telescopes in gold palladium. We wanted to have the best friction possible with a removable component that was also gold palladium in order to get the best friction possible. Those telescopes that now have to be retouched, it's a very, very difficult thing to do. Yeah, 3 teeth on one side, 2 teeth on the other side, and the telescopes. Now we have to make them mirror shine, but they have to be absolutely parallel, 0 degrees. So I would place those things in the mouth, do an over impression, and inside of each of these telescopes I would put some resin and some retentive elements. You see those screws there? Yeah. And then when I cast the plaster over this, I will have a very, very solid model. See, this is resin and retentive elements, metal retentive elements. I cast it and I get this. Now that cannot break. And on this model, with resin abutments, as you can see, this allows me to replace the model at the parallelometer, place the copings, the metal copings over. I will find again the insertion axis. I don't tell you how, it was not easy. And then I would mill it again, refine the milling in metal to make it perfectly 0 degrees like that. Mirror shine. That's the image as they are positioned intraorally. So I had a resin key or index to check if they fit perfectly intraorally and on the model, right? And then it means that if they fit with the same resin key intraorally and on the model, it means there's no difference between the model and the mouth. You have to check all the time because small errors can cause the denture not to sit. I was working until 2 o'clock in the night. I wouldn't do that again. But that was that time, yeah? That was back then. So now you see the removable part. That was gold palladium. Those are the secondary copings over my primary copings. And this was the connector, the main connector, cobalt chromium, and that was to be cemented, adhesively cemented in 4 conjunctors. Look again. That's the final shape. You see the reinforcements for the mobile, for the denture teeth in the frontal region. Gold palladium cemented by these conjunctors with the main cobalt chromium connector. In this image, you see the adaptation, mobile and fixed part. The space remained for the ceramic. Yeah, that was to be, ceramic would have to be placed there. The silicon index that we got from the diagnostic wax-up of the denture. We did it, of course, because we wanted to know how much space we need. That's history. And that was the wax pattern, and now the final denture. I placed a little bit of green wax there because I was afraid that once I cemented, some cement could get in between the fixed and the removable parts. So I wanted to isolate somehow the 2 components, primary and secondary, to make sure that no cement would get in there. Maybe it was overkill, but I wanted to make sure at that time. Yeah, afterwards this wax, of course, was cut. Now this is the upper denture. Here you see the much simpler solution, 4 elements and 2 distal vertical solutions. Yeah, something that, so this we did it like 8 years after the patient had such a denture with spheres, with ball attachments. So after 8 years, the teeth were still there, and we do the same now, but with vertical systems. Yeah, but they are without milling, yeah, without arms and shoulders. It was the maxillary again, so we could do that. We could do that because the palate would limit the sinking of distal sinking of the denture, right? That's the aspect of the denture. Nice that the first teeth are ceramic. You see here the margins of the saddle, the resin saddle. Yeah. And that's the aspect of the whole denture. And this lasted 8 or 9 years. After that, it looked like that, upper and lower. Obviously, in the end, we had to change everything. You see a little bit of pink aesthetic there, or the pink ceramic, just to make it look better. Otherwise, yeah, it's not easy to make it look nice. But anyhow, it's nicer, way nicer than clasps, right, on the surface of the teeth.